Okay, so those are 30, 60s, and 45, 45, 90s. How about these kind where you have to figure out the angle? You can't just use sine of whatever. Let's say I was going to use sine. Instead, I wouldn't use sine. I'd use what? Inverse sine. Another word for that, in case you don't know, the sign with the little -1, that's also arcsine. Okay, have you heard that before? Arcsine, arctangent, arccosine. All right. It just, instead of saying, well, I'll get to that in this problem. This one is telling me to use this and this side, which are the hypotenuse, and which one is this one? Adjacent. Which one has adjacent and hypotenuse in it? Cosine. So I go cosine of theta is equal to A over H. Adjacent is 12 over hypotenuse is 17. So I go 12 over 17. And then this, to solve this for theta, I have to get rid of this cosine. What gets rid of cosine? Arccosine, or cosine with a little -1. And if I do it to this side of the equation, I have to do it to the other side of the equation. So this will cancel out this, and now I got theta is equal to arccosine of 12/17. Somebody with a calculator would quickly crank that out for me. 45.01, let's round it to 45. Okay, so that's 45 degrees. All right, moving on. Let's say you had to find that one. Try it on your own. I'll pause while you do. Okay, so I'm going to use hypotenuse and opposite. So that sine is of theta is 16 over 21. That's going to force me to use arcsine. So I do sine to the -1 on this and sine to the -1 on that. And those cancel. Theta equals sine -1 of 16 21st. And somebody with a calculator and fast fingers, what'd you get? 49.6? Okay. All right, raise your hand if you had the same answer. Good. We're all on the same page on that one. Let's move on. These are like the crazy stepsister. So they're completely opposite. And how are you going to remember which ones go with which one? S goes with C, and C goes with S, and sine or tangent goes with cotangent. Those make sense to me anyway. So a typical scenario is they'll say sine of theta is equal to like 3/4, and then they want the cosecant. Now some people think that we gotta like you do that to figure out what angle it is. I don't need cosecant at all to figure out the angle. If I just gave you that, you should be able to figure out the angle. How would you figure out the angle? Inverse what? Inverse sine. So I'd say, or the arc sine. So I'd say inverse sine of this side, and the inverse sine of this side, and those would cancel, and theta equals inverse sine of 3/4, and you can do that with the calculator. And what this is good for is reciprocals, because these are reciprocal functions. So if I said this is sine of theta is 3/4, then what's cosecant? 4/3. Done. They're just flipped. Okay. Cosine of theta is like 5/9, then secant would be 9/5. And the same idea here. If this is 1/2, this would be 2. Get the idea? And some people are asking me, why? Why do we do those? Well, if we have sine of theta, and I all of a sudden wanted to know what to multiply it by to make 1, that's what reciprocals do. If I take 1/2 and 2 and I multiply them, what do I get? Maybe you never noticed that before. This is what reciprocals do. When you multiply them, maybe they make what? How about 3/4 and 4/3? What happens when I multiply them? I get 1. So what sine times something makes 1. I need its reciprocal. What is its reciprocal function? Which one's reciprocal to sine? Cosecant. So cosecant of theta would be the answer here. All right. Or another way to say the question would be like this: 1 over sine of theta. Let's say that's in a big long equation. Wouldn't it be nice to be able to yoink that out and put something else in? What could you put in for it? Cosecant, because that's what cosecant is. It's the inverse of it. All right, so you're getting the idea. Okay, moving on. This is a blank circle. problem. Fill in the blank. A unit circle problem. Good. Unit means 1. So this has a radius of 1. And if I asked you to fill in this, instead of just saying x and y and do something smarter than that, I'd like you to either fill it in with sines and cosines or tangents, or whatever you could use. Or I'd like you to give an answer as a radical, not a decimal. Don't do that. Okay? So use everything you know about sine, cosine, and that kind of stuff to figure out what should go in those 2 blanks. I'll pause while you work on that. Okay, I could tell I should give a little bit more help. This is x and this is y if you want to like try to figure it out from that perspective. All right, so if you use the 30, 60, 90 to solve it, what did you put for this then? Okay, can I call that a half? All right, if that's a half, then what's that guy to be by 30, 60, 90? 1/2 root 3. Good. And did anybody do it in terms of sines and cosines and that kind of stuff? Because that would have been a good way to do it too. Instead of saying 1/2 and 1/2 root 3, which are good answers, if you use sine of 60, sine is opposite over hypotenuse, right? What would that be? Sine of 60 would be opposite over hypotenuse, y over 1, which is y. So y is sine of 60. So that means y, which is right in this spot right here, the y part would be sine of 60. And you could use a calculator to figure out what that is. If you wanted to give it as a fraction like we did here, that's good. But if you use a calculator, it just gives you a decimal. I suppose you'd end up with a decimal there. This one, even your fraction is so nice that you'd be able to get a fraction really easy. Your calculator, say, puts 0.5, which is 1/2, because it's cosine of 60. All right, so that's 2 different ways I would have been okay with you answering those questions. That's probably the hardest stuff. We're just touching the unit circle a little bit, just so you have a little feeling for next year. You guys are supposed to be advanced so that when you hit the class next year, you're supposed to be the smartest kids in there. So I'm trying to make sure that you're thinking about this stuff a little bit ahead of time so that you're be able to rock next year and straight A's. Any other things you want to know about the test? Could be any questions from the homework that you had or anything that I've been reviewing that you've been struggling with. Okay, nobody's been asking questions all day, so that's fine. If you have individual questions, come on up during work time. I'll be glad to help you